Beneath 8,000 feet of freezing water, off the coast of the Pacific Northwest, the Earth is breathing, not in silence, but in pressure. The ground swells slowly, almost imperceptibly, like a lung drawing air. At the bottom of the ocean, a volcano is inflating. No flames, no towering plumes of ash, just heat, pressure, rising magma. Scientists are watching it in real time, and the readings are unmistakable. Axial Seamount is building toward an eruption, and it may happen in 2025. This isn't speculation. They've seen the pattern before, in 1998, 2011, and 2015. Each time, the ground rose, pressure spiked, and then, suddenly, rupture. And here's the part that chills experts the most. The data today looks exactly like it did before the last eruption. 300 miles off the Oregon coast, a volcanic clock is ticking, and most people have never even heard it exists. But in the world of undersea volcanoes, silence is never safety. It's a buildup. The beast beneath. Beneath the dark, freezing waters of the Pacific Northwest lies a giant few people have ever heard of, but scientists have been watching it closely for decades. Axial Seamount, a massive underwater volcano, rises nearly a mile from the seafloor and stretches across a caldera 6 miles wide. It's not just any volcano. It's the most volcanically active site in U.S. territory, and it's completely submerged. Axial sits on the Juan de Fuca Ridge, a spreading boundary between two tectonic plates that's constantly pulling apart. As magma rises to fill the gaps, the seafloor reshapes itself. This is one of the rare places on Earth where we can actually observe this tectonic process in real time. And Axial is its fiery heart. It first caught researchers' attention in 1998 when sensors detected a sudden drop in pressure, the telltale signature of an eruption. Then again in 2011 and 2015. The pattern was unmistakable. Slow inflation of the seafloor, magma rising, pressure building, followed by a sudden collapse as lava burst out. After each event, the volcano reset and the clock began ticking again. But unlike surface volcanoes that show off with smoke and fire, Axial works in silence. Its eruptions are hidden a mile below the waves, only noticed thanks to deep-sea monitoring gear and remote sensors. It's not just its eruptions that make it remarkable, it's how predictably it behaves. Like a lung expanding and contracting, the volcano inflates with magma and releases it in surprisingly regular intervals. Now, with inflation reaching levels close to what preceded the last eruption, researchers believe the next pulse may not be far off. And this time, the world is watching. The ticking clock. Deep beneath 1,500 meters of ocean, the Earth is holding its breath. At a place few humans will ever see, on the crest of the Juan de Fuca Ridge, something is happening. Not all at once, but steadily, silently. The seafloor is rising, micrometer by micrometer, day by day. For most volcanoes, this kind of buildup would be guesswork, but Axial Seamount, it's wired like few others on the planet. Since its last eruption in 2015, scientists have been watching. Hundreds of pressure sensors, tilt meters, and GPS-equipped seafloor beacons form a dense observational network. They've mapped the slow upward push of molten rock beneath the surface with astonishing precision. This isn't a hunch. It's not speculation. It's data. The numbers tell a familiar story. Before the 1998 eruption, a measurable uplift. Same before 2011. Again in 2015. Each time, the seafloor swelled until the pressure became too much. Then came the breach. Lava spilled, the ground collapsed, and the cycle reset. Since 2015, the inflation has resumed, and in 2023, scientists noted that Axial had regained nearly all of its pre-eruption height. That inflation rate, nearly identical to what preceded past blowouts. By early 2024, researchers from Oregon State and NOAA were already raising flags. If the trend holds, an eruption is likely by 2025. This is the only submarine volcano on Earth where researchers have successfully forecast eruptions in advance. Not because of luck, because of math. Because of machines listening to the Earth's heartbeat, and that heartbeat is quickening when the seafloor breaks. On the seafloor, chaos unfolds in silence. The moment pressure reaches its peak, the volcanic crust can no longer hold. A crack opens, and from that rupture, lava begins to surge. Not in explosive bursts, but in great sheets that race across the seabed like glowing avalanches. Within hours, the ocean floor reshapes itself. The ground doesn't just tremble, it convulses. In 2015 alone, Axial unleashed more than 8,000 micro-earthquakes in the span of just a few days. Each one one a ripple of energy marking the tearing and shifting of the crust. These quakes aren't merely aftershocks. They're the very pulse of the volcano, each tremor part of a geological heartbeat accelerating during eruption. Then comes the collapse. As magma escapes from underground chambers, the seafloor above loses support. Whole segments of terrain sag and sink, meters at a time. In some places, dramatic drops have been recorded by sensors, as if the ocean bed had taken a breath and then slumped in exhaustion. Though Axial's eruptions don't hurl fire into the sky, they are no less dramatic. These are effusive eruptions, pouring lava steadily and rapidly, coating the seabed in fresh, scorching rock. Entire underwater landscapes are buried. Pillows of basalt pile up. Thermal vents that sustain delicate ecosystems vanish in an instant. Tube worms, crabs, and microbial life, entire colonies that may have thrived for decades, are wiped away. But in time, new life returns. The heat, the minerals, the chaos, they also spark regeneration. Nature, it seems, adapts to disaster. Still, each eruption writes a new chapter in the geology of the Pacific, and each one reminds us how thin the boundary is between the stable seafloor and the volcanic machine below it. And right now, that machine is winding up again. The scientists watching, far from shore, a web of instruments is quietly listening. This is no ordinary surveillance. It's the Ocean Observatories Initiative, or OOI, one of the most advanced Earth monitoring networks in the world. Strung along the seafloor like nerves in a body, fiber optic cables stretch across the Juan de Fuca Ridge, plugged into sensors embedded around Axial Seamount. And these sensors don't sleep. Every twitch of the ground, every degree of thermal shift, every subtle tilt or uplift, it's all captured and transmitted in real time, straight to labs on land. Through this system, scientists don't just react to eruptions, they anticipate them. Volcanologists Bill Chadwick and Scott Nooner have been tracking Axial's behavior for decades. What they're seeing now is familiar, too familiar. It's inflating again, Chadwick reported. The ground is rising just like it did before the 2011 and 2015 eruptions. Nooner added bluntly, it's playing out again? Almost exactly. The seafloor is bulging, not figuratively, but literally. Instruments show it rising centimeter by centimeter. It's a slow, steady signal, like the minute hand of a clock, ticking toward an inevitable hour. The precision of this monitoring is staggering. It's as if we've placed a stethoscope on the Earth's crust, and now we're hearing the same murmurs that came before eruption last time. A heartbeat growing stronger, a volcano gearing up, and the people watching it? They're not wondering if it's going to happen. They're watching to pinpoint when. Could it trigger a tsunami? Let's get one thing straight. Axial Seamount is not Krakatoa. It's not going to blow the ocean apart in a towering mushroom cloud of ash and fire. That's not how this volcano works. Axial is a basaltic shield volcano, and its eruptions are usually effusive, meaning lava oozes out rapidly but not explosively. No violent blasts, no columns of vaporized seawater, and under normal circumstances, no tsunamis. But there's a twist. The danger doesn't come from lava shooting into the sky. It comes from what happens underneath and how fast it happens. Axial Seamount sits on a rift zone that's constantly stretching. During past eruptions, its summit suddenly collapsed. Imagine a massive bowl caving in, dropping several meters in hours. If that collapse were accompanied by a steep flank failure or a major underwater landslide, it could displace enough water to send waves speeding toward the Pacific coast. It hasn't happened before, but the geological ingredients are there. Scientists at NOAA and USGS have studied these scenarios. The risk is low, but not zero. Modeling shows that in a worst-case collapse, areas along the Oregon and Washington coasts could see localized waves, not city-drowning tsunamis, but enough to cause damage in vulnerable harbors. There's no reason for panic. Axial is not a coastal killer, but it reminds us that even quiet volcanoes, especially those hidden underwater, can hold surprises. And just because the eruption might happen far offshore, doesn't mean we're entirely out of reach. Systems and preparation. In a control room thousands of miles from the Pacific seafloor, a blip appears on a monitor. Pressure drops. Seismic chatter spikes. Within seconds, scientists know something is happening deep beneath the waves. That's the power of today's ocean surveillance networks. Thanks to a web of instruments strung along the seafloor, pressure sensors, seismometers, tilt meters, the warning time for an eruption like Axial's is no longer theoretical. These systems now stream live data through fiber optic cables, straight from the ocean floor to researchers on land. One of the most advanced networks is the Ocean Observatories Initiative Regional Cabled Array, which connects directly to Axial Seamount. Unlike past decades where eruptions were only discovered after the fact, Today's scientists can detect inflation, seismic activity, and lava movements as they happen, and even forecast eruptive cycles with surprising accuracy. But what happens when something does erupt? Alerts can be pushed out in minutes. NOAA and USGS systems are integrated to notify researchers, emergency responders, and maritime services almost instantly. While an axial eruption wouldn't devastate coastal cities, it could still pose a real-time threat to ships operating in the area, especially research or cargo vessels passing above the site. There's also the risk of damage to undersea infrastructure. Axial Seamount lies near key trans-Pacific data cables, the same lines that carry internet and communications traffic across continents. A lava flow, if it reached far enough, could melt or shift segments of this hardware. And even if the eruption stays localized, the massive shaking and collapse events could generate seafloor instability, putting this fragile network at risk. Then there's the question of science itself. Instruments that track long-term climate data, like carbon measurements, ocean currents, and deep-sea temperatures, are often mounted close to volcanic ridges. An eruption could bury them or wipe out years of valuable research in seconds. So, while the eruption might not make headlines on land, it could send shockwaves through the digital and scientific world. And that's why the ocean floor is never left unwatched. The next eruption. It's a quiet countdown, measured not in hours or days, but in pressure and time. Since the last eruption in 2015, the ground beneath Axial Seamount has been swelling again, almost at the exact same rate as it did before it last blew. Scientists call it inflation, magma rising into the chamber below, pushing the seafloor upward by dozens of centimeters. It's not a theory. It's recorded, measured, charted in real time by sensors anchored to the seafloor itself. Each day the pressure builds. The timeline isn't vague anymore. The last two eruptions, in 1998 and 2015, came almost like clockwork, roughly 17 years apart. But what's eerie is how closely today's inflation data matches the pattern from just before the 2015 eruption. According to geophysicist Bill Chadwick and marine geologist Scott Nooner, the seafloor has already risen more than 60 centimeters since then, the same threshold it reached just before it cracked open last time. That's why 2025 isn't just a guess. It's a projection built on pressure curves, seismic upticks, and historic cadence. The mountain is breathing in again, and when it exhales, it won't send smoke into the sky or shake cities awake. There will be no towering plumes or flashes of fire, no warning most people will ever feel, just a sudden pulse from the deep and the ocean floor cracking open again.